Hello. Good morning, all dear students. Very few students are there. Please join all of you. Uh, Good morning, all my dear students. Please, I'll check. Am I audible? And my screen is visible to you. Please respond me, anyone.
Yes, sir.
Okay, thank you. Only six students are present. What about remaining? Okay, anyway, I have to continue with this already 5 minutes. I waited for them. So, in the last lecture, I was completed second unit of your microprocessor. So, is there any doubts from the second unit or even first unit? So, totally 2 units I have to cover. First unit, introduction to microprocessor, and second unit, that 8086 assembly level machine language. So, from these two units, is there any doubts or you facing any problems, any topic you are not understood? Please discuss with me for this 5 minutes up to again the joining all the students. Please raise the questions and ask me anything you not understood properly. See, always you have to do study regularly. Once you are covering the portion regularly, automatically some doubts are arises. If you are not asking any questions or any doubts, it means only two things. Either you have to understood everything, then no question, or you can't understood anything, then also no question. So which mode you are, we want to recognizing is very difficult. So online. So for that, always you try to ask the questions and get clarified the doubts whatever you have. So if no doubts, no questions from the unit number 1 and unit number 2, then I will move to unit number 3. So in the unit number 3, we are totally studied assembler instruction formats. The all the instructions, whatever comes under the microprocessor, all those instructions we have to study in this unit number 3. According to the coverage of these instructions, we also started with the lab session from third unit onwards. Today, whatever I am going to start. Okay. From this parallelly, now onwards, parallelly, we have to start lab session as well as theory session. Okay. So every day I have to cover some of the instructions, whatever comes under the unit number 3. Based on instructions, we will do we will start with small microprocessor programs, and also along with lab session programs, and we have to cover parallelly now onwards lab programs as well as uh, theory session. So here, as per syllabus, that is okay. So this is a syllabus for you. So as per syllabus, uh, these 2 units I have to cover in previous days, and today I am starting with this unit, that is the unit number 3rd, assembly language programming. This is a 6 hours unit. Only in this unit we are going to study all the instructions. So for that, this unit is very important for your exam point of view, for microprocessor knowledge point of view, for lab session point of view. Entire this microprocessor is depends upon this unit. So I request you all, please don't miss a single lecture, and please be busy with this lecture up to completion of this lecture, and each and every instruction you must and should understood, then only you are very much user friendly this subject becomes. Okay, so let's now uh, yes please, anything else? Okay, so now I have to start with this 3rd unit as per your prescribed syllabus, assembly language programming. In that, assembler instruction format and 8086 instruction set. So these 8086 instruction set are nothing but all the instructions, minimum 70 to 75 instructions we are going to study in this section. And at the last topic, very one small topic, that is directives. So the 6 hours, minimum 7 to 8 hours, I have a plan to complete this unit. Okay, so come with the notes. So before that, I have to send you the notes first. So come to the microprocessor group, that is microprocessor. Okay. So I'll send you the notes before started for your reference. It is easy for you to carry along with my lecture. Okay. So chapter 3. As all of you come to the microprocessor group, DSY group, it's loading. Yes. Yes, it is dumped. So go and check it out. See unit 3 notes. Okay. So very well defined again, like notes 1 and notes 2. These notes also I have to prepare for you. Yes. So this is your notes. First topic is, what is first topic? That is assembler instruction format. So we'll start with the first topic. So once I will check, am I audible and my screen is visible to everyone, please?
Yes, sir.
Yes, sir. Okay, thank you. Yes, we will start the actual topic of third unit today. And parallelly, lab session also we have to start from this week onwards. Okay. So, dear all students, in the previous two units, like unit number one, introduction to microprocessor. So, in that you have to study just definitions of microprocessor, components of microprocessor, system bus you studied, features of 8085 microprocessor, and pin configuration of 8085 microprocessor. And at last, you studied architecture of 8085 microprocessor in the first lesson, first unit. And again, in the second unit, you studied the architecture of 8086 microprocessor, features of 8086 microprocessor. After that, you studied that addressing modes. There are two types of addressing modes: data related addressing modes and branch related addressing modes. In the data related addressing modes, you studied again five subtypes, that is immediate addressing mode, register addressing mode, register relative addressing mode, indirect addressing mode, direct addressing mode, and implied addressing mode. These are the data related addressing modes. And in the branch related addressing modes, you studied four subtypes, that is intersegment and intra-segment, in direct and indirect. Okay, intersegment, direct, and intra-segment, indirect. Like this four category you have to study. After that, timing executions you studied in the unit number two. So the after completion of this basic things of 8085 and 8086, now we are going to study what are the instructions or comes to do the particular task for the microprocessor program. We have to study this third unit, that is assembler instruction, that assembly language programming. In that, the first topic we are going to start assembler instruction format. Okay. So in the format, this is the format actually. So at the see, this is the one instruction. For example, add. Add means is a one instruction. So this is used for addition. And the AX, after the add instruction, we have to use it AX. AX is nothing but what? It is a register. A is a register. So as you studied in the architecture of 8086, A, B, C, D, E, right? B, C, D, E, you have to study it. So these are the registers used for storage purpose, storage the data. And count bx. Bx is again one more register, that is for the operation of counting whatever the values or data are containing. So, and this is the one br branch. For the branch, if for the looping, even C programming also you are using looping, right? To form the looping, or again be re back to execution of the reverse code. So that time we have to use the branching. So entire this format is nothing but branching colon instruction and register and register. This AX is a one register, we call it as an operand, and BX is also one register, we call it as another operand. So here for the branch we are going to label it. It provides, label means provides a branching to these instructions. We have to going to connect it to some other line of the program for the needful line of the program. And that add instructions, we say it is a mnemonics. We say it is a mnemonic because it is a single. And AX and BX. AX we call it as destination operand. AX we called it as destination operand, and BX we called it as source operand. So always we have to transfer the data from source to the destination. At the rightmost side, always we call it as source, and left side we call it as destination. And this is the mnemonic, is nothing but an instruction, and this is the branch is going to be connected wherever our code is going to be necessity of execution. Okay, so this one I have to give a single explanation in a single place, that is label mnemonic, operand 1, operand 2, and like you have to use the comments, means the double slash you are using in the C programming. So here you have to use the command also by using the colon. So this is the format of assembly instruction. Label, colon, mnemonic. Label is optional. If you need, then only you have to use label, like your branch in this example. Okay. Mnemonic is a compulsory. Operand 1, operand 2. Operand 1, we call it as a destination point. Operand 2, we call it as a source point. Always the data is transferred from the source to the destination in this sequence. Please be remember, the operand 2 to operand 1 we are going to transfer as per the instruction of mnemonic, as per the instruction of mnemonic. So here the first one is a label. Label is what? It is for the identifier purpose we are using to connect the branch. This clear explanations I have to give. Just a single sentence. It is connected to wherever necessary things. And this mnemonic is nothing but what? It is a instruction. So all the instructions must contain a mnemonic. It is nothing but a instruction. And these two are the operands. The presence of operands means operand 1 and 2 instruction of instructions have a no operands, and some instructions have no operands also. But mnemonic is compulsory, and some have one operand or some have two operand. This sentence you have to carefully take. Some instructions have no operands, and some have one operand, and someone have two operands. If there are two operands, then they're separated by comma. Always here there is a one comma with the different uh, operands. Okay, and after that you have to separate with the comments. That comment field is for commenting in the program, like you are using the comment lines, right? In the C programming also you have to use it. Like that here by using the comma, you have to use the comment lines. So this is the instruction format, and an instruction may be contained into another lines of placing an ampersand. Ampersand means what? It is an address operator. It's a address operator at the beginning of each the continuation lines. So that is the hold the address of another variable, what we say. And in the assembler language, the instruction must have an operand for each machine language instruction operand, and the operand must be sufficient to indicate the operand's addressing mode. If there are two operands, the destination operand appears first and the source operand second. So right side we say it is a source operand, and left side one we say it is a destination operand. And this is the mnemonics, means in instruction. And if we need, we have to use the label nothing but a branch as per this example. Okay, so here again I have to mention some of the points, that is addressing mode with the data related addressing mode. What are the mnemonics we have to use it here? So immediate, direct, register, register indirect, and register relatives. Already these are we have to explain. Okay, and this is the format of that constant plus expression. All these you have to study it in the last lecture. So just for the one on examples I have to given for your again the replacement. And addressing modes like based index, relative based index, and in the branch related, that is intersegment direct and indirect, intersegment direct and indirect. These also already we have to study it. Just for your replacement I have to done in the notes. Okay, so now actually we have to start it with the some of the rules, that is naming conventions, and also the string constant of a character. So again here we have to study different types of operations also, like arithmetic operations. Those are nothing but addition, subtraction, multiplication, and division. This is the first program for your lab sessions. Okay, that one also we have to start. And logical operations like your operators and, or, not, NAND, XOR, XNOR, like that. These are the logical operations. And sub expressions for eliminated, for modification, for deleted also we have to use. And for the name, that is identifier factors represents constant, string constant, or expressions. So these are the things we have studied. Okay, for the coverage of these things, we need to study the instructions. So for the instructions, we have to follow some rules in order to present for the operators is the same as it is high level language because of machine level language, and an identifier may be label, variable, or a name. So identifier means what? These are the keywords. So which can, it may be a label, it may be a variable, it may be a name, consist of string of up to 31 characters. Okay, and those characters must be letters, maybe a letters, maybe a digits, maybe a question marks, maybe a underscore, or maybe at the rate symbol, or maybe dollar symbol. That's the first character. But only thing is that the first character cannot be a digit. That rules you have to follow. And the identifiers cannot be a keywords always. Keywords is different, identifiers are different. Identifiers are user can create. Keywords are built in, that is fixed with the tool. So that identifiers cannot be a keywords, because if you have to use the keyword as an identifier, again the compiler will get conflict. It is comes from which either is it identifier or is it a keywords. So you have to go into categorize it into these by the assembler, and such instructions, mnemonics, register names, and special operators. Okay, so this is just a basic idea for the instructions, and entire this thing already we covered in the unit number first and unit number two. So actual the, and this is the part of just instruction format. This is the part of the just instruction format. What is label? We have to study. What is mnemonic? What is operand one, operand two, and in the operands, which is a source and which is the destination. So always in this format, you have to remember right side operand we call it as a source operand, and left side operand we call it as a destination operand. Always we have to transfer the data from source point to the destination point. So this one formula you have to remember. This is the that label format. So if you perfect with this format, and you are very easy to write the instructions along with the operands, needful operands for the particular operations. Okay. Yes. uh, Now we'll start with instructions. So data transfer instructions. At the first, how there are two categories are there in the addressing modes. What are the two categories? Can you tell me, anyone? In the addressing mode, what are the two categories? All of you there? No voice? Hello?
Data related addressing mode and branch related addressing mode.
Yes, very good, very good. So there are the two types of addressing modes: data related addressing modes and branch related addressing modes. So in here also in the instructions, uh, we have to study all the different kinds of instructions. First one is data transfer instructions. Data transfer instructions we have studied. Mathematical instructions we have to study. Logical instructions we have to study. Increment, decrement, and shift to right, shift to left, with carry, without carry. So many categories are comes under this instruction set. One by one, we have to cover now onwards. So here in the data transfer instructions and in the questions, if the offline questions, sometimes they may ask the question, explain the data transfer instructions with an example. So these are the data transfer instructions: move instruction, push instruction, pop instruction, exchange instruction, XL80 and LES, push, F, pop, F, LEA, LDS, in, out. These 12 instructions are we called as data transfer instructions. Why we call these are 12 instructions are data transfer instructions? Because these 12 instructions are using to manipulate the data, that is transfer the data, modify the data, update the data, delete the data, add the data. So whatever different kinds of operations are comes with the data, all those operations are covered in this category. That's what we have to call this one as data transfer instructions. And whatever I mentioned, all 12 instructions, these all 12 you have to explain in detail if this is the question in the examination. Okay. So in that data transfer instructions, I have take first one as a move instruction. So that is the first one is move. So this is the format of move instruction. So move is what? Here label you leave it. Label only you have to use it if it is necessary. So move is a mnemonic called as an instruction, and destination is a operand 1, source is a operand 2, and these two operands is separated by a comma always. There is a format, and here in the colon label is there, but label is not it, that is optional. That's what I didn't use the label. So mnemonic move, destination is the first operand, and comma next, source is the second operand. So in this, for example, here move CX0037H. H indicates that is a hexadecimal number of 37, and this is a one operand. CX is a one register. Move is a mnemonics. Move CX comma 0037H. It means that the 37 hexadecimal value is transferred it into CX register. That's the meaning of 37 transferred to CX register. So that CX means what? 37 arrow mark you have to check that 37 is placed into CX register. Move BL comma 4000H. It means that the 4000H, it's a relative addressing modes. Bracket is there, you have to check. In the relative addressing modes means what? It is a holding the address of some other value. That some other value address only we have to transfer to the BL register. So C, B, A, D, these are the register, and X and L what? X, L, H we are using. X means either it may be a L or H for the 16 bit, and if it is a 8 bit, then we have to use it only L. We have to use it only L for 8 bit, and 16 bit we have to use X. X in the sense either it may be a H and L. H is 8 bit and L is 8 bit. L is for low, H is for high. So 16 bit we have to indicate it by X, C register, and L means that is B register is 8 bit. So move AX comma BX means what? The whatever the value is containing BX register, that is transferred it into AX register, source to destination. Here also move DS comma BX means DS means what? It is a data segment. 4 segments you have to study: data segment, stack segment, code segment, right? So 4 segments you studied. So the BX is what? It is a 16-bit register. That 16-bit register containing a value is transferred it into BX DS register, means data segment. That is by the help of move instruction. So this is the meaning of move instruction. Okay. So very clear. Move instructions we have to use to transfer the data from source to the destination point, and these are the some examples what I explained. So just you go through it, very easy. The thing is difficult. So next instruction is push. The instruction number 2, that is a push. Here in the push source, we have to only one source is there. Why one source? If we want to push and pop, you may study. Push means you have to enter the data into the stack, and pop means you have to remove the data from the stack. So here in the push source into stack and decrement the stack pointer by 2. So how you have to enter the data into the stack, that is decremented by 2. So that's what, as per the move instructions, here we have to use the instruction as push. Instruction as push CX. Only one source register. It means that the stack pointer minus 1 in the push operation and stored it into stack segment. Yes, yes, it means that stack segment. And finally, the stack pointer minus 2 becomes a and stored it into stack pointer. Same way, in the data segment, that is also that stack sp minus 1 and sp minus 2, totally 2 times, that is sp minus 2 to the stack pointer and stored it into the stack segment. That is the push source. Same way, pop is the opposite of push. Push means you have to enter the data, but pop means you have to remove the data or delete the data from the stack. So in this, again, the destination is transferred with the expectation of 4 segment memory location. So pop instruction is pop cx. It means that it is a reverse of push. So sp plus 2 in the stack pointer. Opposite of push. Push means enter the data. Stack means remove the data. Same way at the data segment, pop with the stack segment to DS register. That is addition plus. Here is minus in the push and in the pop. So this is a push, this pop operation, push operation, and move instruction. So next one is push F. Here the F indicates that is the flag. Flag is means what? Either in the high state or in the low state. If it is high state, you have to remove. If it is low state, it is active. Active and inactive. One means inactive, and extra you have going to do the work on that. So here in the push F, that is the push value of flag register into the stack and decrement the stack pointer by 2 as your push. Same as it is a push operation, only with the flag register. How? So push F. Here we have to use it only a push F with no source and no destination we are using. So for that, beginningly I have to say operands are maybe 0 operand means no operand, maybe 1 operand, and maybe 2 operand. So in the stack pointer, that is stack pointer minus 1, in the push minus 2, in the push totally stack minus 2, which is the flag register. Same way in the pop F, pop with flag register, that is addition of 2. So a stack pointer plus 2, either if it is high or low conditions, that we have to use pop F. Okay. So after that, we will go for fifth instruction, that is pop F is the XCHG. That is the XCHG and XLAT. So here XCHG means what? This is the exchange short form. So exchange source to destination and destination to source. So to exchange a byte or a word between the source and the destination, it means that swapping between these two registers. Source to destination we have to transfer and destination to source we have to transfer. Yes, okay. Actually, I got a one call. Sorry for that. Hello. So, am I audible right now?
Yes, sir.
Okay. Okay. Sorry for that. I received a call to the emergency. Okay. Now we'll move to that exchange instruction. In that exchange instruction, uh, that is a destination source, because to exchange, to swap the two values or two data or two information from one on another, source to destination or destination to source, that time we have to use exchange instruction. So in that exchange, a byte word between the source and the destination specified in the instruction. So the source register is a memory location and destination register is also a memory location. Both are registers. Here, for example, XCHGBCXBX. X in the sense what? It is a 16-bit register. C and B are the register with the 16-bit. So that BX register, whatever containing the value or a data or information, that one we are going to transport it into CX register by the help of XG, and as well as whatever the value containing a CX register, that is transported into BX register simultaneously. That's what I have to show here. Both the side arrow mark, it means BX to CX and CX to BX transferring. Same way in the second example, XCHG BL comma CX. So it means that BLE means what? That is a B register of low bit, means 8 bit, and CH means C register of high bit. High to low and low to high we are transferred. So again, both side indication of arrow mark, CH to BL and BL to CH. Okay, so this is the sixth instruction. Next is XL80 BR XL80 normal. Either this one you have to use it or only XL80 you have to use it, this list. XL80 or XL80B in the instruction number 7. So in that, move into the EL register, that is XL80. Here we don't use any source and destination, but that contains of the memory location in the data segment whose effective address XL80 we have to use it for only effective address. That effective address in the addressing modes you studied. Okay, physical addresses, effective addressing, and is formed by the sum of BX and the AL. So XL80 is AL, DS, BX plus AL. This one is a relative addressing that is transported into from the data segment. DS means DS of data segment to the accumulator, or AL we say it is accumulator is nothing but A register only, that low bit. H means high bit. So here, for example, if DS is having 1,000 hexadecimal value and BX is a 200, then AL is a 03H. So here 1,000 up to DS with a 16 bit, because X is nothing but it is 16 bit, and 1,000 DS into 16 plus 200 with the BX and plus 03 with the accumulator. So totally 1020 effective address what we are calculated by using the XL80 instruction. This is XL80 instruction used for to calculate the effective address in the addressing modes. So next instruction, LEA. LEA in the sense what? Loads effective address. Here clearly I have to mention loads effective address. After getting the effective address from the XL80, we have to use that XL80 effective address, that is loads effective address, that is register and source. So if the source into the given register, that is for example LEA load effective address BX comma total. So it means that whatever the total value of offset address, like this one here in our previous case 1020, offset address of total value transferred it into BX register by the help of load effective address. Load the effective address EA into the BX. That is LEA register, and here we have to use a register, and this is a source. For the source, anything we can use. Okay. And in LDS, so in LDS, destination register and source, three are we need, because this is a destination register and the source. So loads the destination register. LDS means what? Loads the destination register, and DS register with the offset address and segment address. So, and it is specified by the source. Okay. Loads destination address, that is LDS. Here in our example, LDS BX comma total, it means that the total of DS and the total of DS plus 1 means total plus 1 is transferred it into BX register. So that is the LDS. And in the length instruction, 10th instruction, LES, it's a load destination, and this is the load loads the destination register with the offset address and the segment address indirectly. It's with the indirectly, but here directly we have to load, but LES it is a indirectly we have to load. That is with total plus 1, that is DS to the BX. So total to the BX register by using the LES. This is directly loads, it is indirectly loads. This 10th one. Okay. So all these 10 instructions we have to study. These are the data transfer instruction. The data transfer instruction, and again two more are there, in and out instruction. So in and out instruction also we have to study. Okay, now we have to study this. In and out are nothing but what? IO means in and out addressing modes of 8086. Again, two categories: in instruction and out instructions. So here, that is direct addressing mode and indirect addressing mode, like in and out. So for that, in instruction, here we are using destination register and a source port, because particular locations, from the particular locations we have to transfer to the destination register. So it loads the destination register with the contents of the input and output ports specified by the source, and that source is nothing but what? Here is the IO port address. This one source port is nothing but it is the IO port address. If the address is 8-bit, it will be given by the direct addressing mode, and if it is 16-bit, again it will given the DX register using a indirect addressing modes, because in the 16-bit, two section 8 plus 8, X H plus L, and destination, this is destination, always we have to use it for accumulator like A register with a low bit AL and AX, that is in the in destination source point. So, and next one, these are the examples in AL comma ATH. It means that what? That ATH is a port which is transferred to the destination AL accumulator value. That is in operations, in instruction. Same way for like that, we have studied out instruction, that out destination port, that is source register. So it can load the destination port with the contents of the source register. So in that, for example, out ATHL means, so this is related to output and it is related to input, in and out ports. Okay, so it is from the input to the accumulator, it is transferred, but here from the accumulator to the output. So here ATH is comes in the first line, that destination point, and these registers are comes at the source point. Only reverse destination and source, it becomes automatically out instructions. In instruction is used for data to accumulator, out instruction is for accumulator to data. These are the accumulator transfer to data. Okay, so 12, these are the 12 instructions. All these 12 instructions are nothing but data transfer instructions, move instructions we covered, push instruction, pop instruction, and push F, pop F, exchange, XLAT, loads with directly, loads with indirectly, LES, and in and out, all needed to explain you as per my given explanation. Okay, so just this much you have to explain. It's more than enough for your answers. So, and in that 10 I have to use it clear data transfer, and 2 I have to use it for in and out. So dear all students, now it's 10:20. 10 minutes I will give you the time, up to 10:30. You read it, whatever the instructions I covered, all 12 instructions, just you read it. Again, I'll start lecture at 10:30 with the next topic, that is program execution and transfer instructions. Up to now, what we studied, data transfer instruction. Up to that, we studied execution instruction. So I'll give you 8 minutes time. Please, all of you go through all the data transfer instructions. So up to that, I'll start with uh, program execution instructions. Okay. So please carry on 10 minutes. Please mute it. Don't make disturbance to others. Okay, dear all students, actually, I done a mistake while sending. So I sent to regular group. So now I sent the notes. Please, all of you go through it. Okay. Okay. Actually, one student only replied. So what about other students are doing now? Why you not replied? Why you not told me? It's okay, fine. I think now it is available now. Now is it available?
Yes, sir.
Okay, okay. Now you go through it. Okay, okay. Leave it. After that, you will go through it. Again, I will continue with the lecture. So all of you be concentrate on here with the lecture. So next, now it's 10:33. 10 minutes is over. So next, I will start with program execution and transfer instructions. Program execution and transfer instructions. So in this program execution, these are the exact reflection of your lab session programs. So the instructions which are going to use it for execute the program, microprocessor program, that's purpose we have to use program execution and transfer instructions. So these instructions are caused by a branch in the program sequence. There are mainly two types of branching, that is near branch and for branch. So label you are using now at the before the mnemonics, that is optional. If you need, we have to use label. So in that two categories, there is a near branch and a for branch. So in the near branch, we call it as intra-segment branch, and the far segment we call it as inter-segment branch. So in that branching, here we have to use jump conditional jump. That is jump branch. That is with the conditional jump. So in that intra segment called as a near and inter segment called as for. Inter segment means it is for and inter segment means it is a near. Again into these two categories, intra segment indirect jump and inter-segment direct jump. Here also in the for inter-segment indirect jump and inter-segment direct jump is here. So in this intra-segment indirect jump, the new branch location that is specified directly in the instruction, and the new address is calculated by adding 8 bits or 16 bit 8 bits or 16-bit displacement to the instruction pointer IP, and the code segment does not change, that is remain same as it is. For the positive displacement means the jump is ahead in the program, and for the negative displacement means the jump is behind in the program. Ahead and behind in the program. So for that, the jump means the previous and the jump means next. Previous means uh, previous means that behind, next means ahead, front and back, what you says. Okay, so this is for intra segment indirect, and intra segment indirect jump for the new branch address is specified in directly through a register or a memory location. So the value in the instruction pointer is replaced with the new value of whatever they are generated, and the code segment does not change. Again, it is a remain same. So for example, jump word ptr bx means that bx pointer to the word is transfer is jump into required positions of data segment with a bx register with a +1 address point, that is intra segment indirect jump. Again we are start with inter segment direct jump. The new branch location is specified directly in the instruction, and the segment and instruction pointer gets a new values in the inter segment. So for that, the jump next segment, that is code segment and instruction pointer get the value from the label next segments. Okay. And inter segment indirect jump, there's a new branch location is specified indirectly to a register or a memory location, and both the code segment and instruction pointer get a values. For that, the jump D word, data word, PTR BX. D means what? Data word. So BX plus 1 and BX get transferred to the instruction pointer. Or if it is data segment, that is a code segmentation. So these are all four intersegment and intra-segment, direct jump and indirect jumps. Okay. Next, J condition, that is conditional jump. J and Z is an unconditional jump and J condition is a conditional jump. So in that J conditional, this is a conditional branch instruction. If condition is true, then it is similar to the intra-segment direct jump. And if its condition is false, then the branch does not take place next sequential instruction for the execution. So the destination must be in the range of 128 to 127. It means that total 256 a band from address to the instruction. So in shortly we have to say that is JNC. J condition we say JNC, and non-condition we say JNZ. Jump JNP. Okay. So JNC next, it means that jump next if carry flag is not set to the various jump instructions are as follows. So jump instructions JC, jump on condition, jump on carry. JC means, JNC means jump on not carry, jump on equal or jump on zero, jump on not equal, jump on non-zero, and jump on parity, jump on even and parity. So JNP means again no parity, JPO means odd and parity. So these are the flags in the table I have to mention with a carry flag 1, with a carry flag 0, 1, 0 like this. That is mnemonics is the instruction and this is description which is equity or odd or even or with carry, without carry, or with parity, without parity. Okay, so these are the manipulation with the jump instructions. And also JB means jump below and AE means above or equal. Above or equal or below. JBE means again below or equal and above. So these are the below above four instructions, and with a parity, with a carry, and odd and even. Again 6 instructions. So totally 10 instructions you have to remember. So along with that, overflow, JO means jump on overflow. JNO means jump on not overflow. Jump on sign, yes, JS. And JNS means jump on not sign. JL means jump on less. JG means jump on greater or equal. JLE means less or equal. So these are the some jump conditions we have to use it. And JG means what? Jump on greater. So based on overflow, sign, greater, lesser, greater or equal, lesser or equal. So these are the again 8 instructions in the jump only. So these are the jump conditional and jump unconditional instructions. Next in the third category, call, unconditional call. In the third category, unconditional call we have to study. So call is an instruction that transfer the program control to subroutine with the instruction of coming back to the main program. So thus in the call saves the stores address of next instruction in a stack before the branching to the subroutine. For in the call unconditional, end of the subroutine controls transfer back to the main program using the return address from the main stack. So here, for example, again intra-segment call and inter-segment call. So this first one is intra-segment call. That is for the example of call sub add. It means that subtraction and addition we are going to call with the stack pointer from the stack -1 and -2 to the instruction pointer. So that is stack pointer is nothing but stack pointer -2. So new offset address of subtraction and address addition will be happened with the intra-segment call. So next is inter-segment call means fall. Here the new subroutine called is in the another segment. Here is a CS and instruction pointer. Both get new values. So the call address can be specified directly or through register or in memory locations. That is with the push CS decrement, push IP decrement, and loads code segment, loads instruction pointer. For example, call subtraction addition with the stack pointer of -2 is stored into stack pointer like this. That is a inter segment, inter call, and intra call. So in the fourth category, that is return instruction. That return instruction is used for what? Just it is going to be return the statement. So RET instruction is caused to control to return to the main program from the subroutine. That time we have to use RET, main program to subroutine. So in that also again intra-segment return and inter-segment return. Intra-segment means inside going to be writing. Inter-segment means outside of the memory is going to be writing. That is SP+4 here. Okay. Intra-segment and inter-segment return. So these all are whatever I explained now. These all are conditional, jump conditional return statements. Okay. So that is program execution instructions. So whatever I have to study or I covered, that is program execution instructions. So dear all students, please you have to go through it. So notes I sent to you, all of you collect the notes from the microprocessor DSY group. Okay. So take these notes. Now you have to start to study today's two category of instructions I have to cover. One is data transfer instructions and the second one is program execution instructions. So what are the two topics I have to cover? Data transfer instructions and program execution instructions. Please you have to carry, and in the next class onwards also again we have to cover some more instructions, and along with that we cover lab sessions also. Okay. So dear all students, I have to stop here my lecture. Remaining 15 minutes, what you will do, just you have to go through my notes whatever I covered today, and clearly line by line you have to do study. You have to do study. If any difficulties, please let me know. Up to 11:30, don't log out. You be log in and you have to do study. Okay. So yeah, if any doubts, anything you not understood, please let me know. Ask the questions. So if no questions and you have to start study, if questions you ask me.